This is a project on erosion completed for Module 2 of ACTE 655 Integrated STEM by Nicole Shoemaker. Some background on this project. The Earth cleans water through the process of infiltration, but our building practices often reduce infiltration and increase runoff. So the question is, how can we best design the landscape to encourage infiltration and thus minimize runoff? During the Imagine step of the process, I did some research. I used the watershed simulator to model runoff and infiltration, and you can see that with the same amount of rain, you get either 0, 1.9 centimeters, or 4 centimeters of runoff, and either 7.7 centimeters, 5.8 centimeters, or 3.9 centimeters of infiltration, all depending upon the Earth's surface. And here I used a forest, a mildly developed area, and a moderately developed surface for a model. I also took a look at an experiment completed by someone else that was a bottle type erosion experiment. So for my planning stages, I gathered some materials and I tried to see what materials and setup would allow me to have water flow over different surfaces and model runoff and infiltration. I went with bowls rather than bottles, a cup to support the bowl to allow for runoff and another cup to catch the runoff. I chose 5 different surfaces, regular soil as a control, rubber tire mulch because I wanted to see if it was really as effective as natural mulch. And then I did a natural mulch, a rooted grass, and some flat pieces of stone to simulate a paved surface. Living in suburban Lancaster my whole life, I've definitely noticed our tendency to continue to build on our farmland and pave parking lots. And I really wanted to be able to compare those surfaces, kind of given my life experience. So during Create, my trusty assistant and I created the 5 bowls and assembled them on the stands that I imagined. And during our testing, we were ready to pour the water and test the runoff and infiltration for each model. We used a standard amount of water for each model, 2 cups, and we attempted to pour it in a standard method. I took pictures of the results and measured the amount of water runoff we got from each surface. So the results, the soil only control showed the most amount of runoff of soil and also a large amount of water runoff. We got back 1 1/4 cups, so fairly little infiltration. Rubber mulch showed much less runoff of the soil, but we still got 1 1/4 cups of water runoff, so again, pretty little infiltration. Our pavement model showed little runoff of soil, but also very little infiltration, so we got the largest amount of water runoff from the pavement, 1 1/2 cups. Natural mulch, which was leaves and twigs and things, showed very little runoff of soil, but pretty good infiltration as well. We only got 1 cup of water runoff. And rooted grass showed almost no runoff of soil and pretty good infiltration, the least amount of water runoff from that model. It was less than a cup of water that we got back. To improve, I might make larger bowls or bottles for modeling. I might use a watering can to simulate rain better, or use 1 piece of pavement instead of just several flat stones, which is all I had. Standard alignment according to the next generation science standards. This would be under Earth systems, make observations and or measurements to provide evidence of the effects of weathering and the rate of erosion by water, ice, wind, or vegetation. Under practices, it would be making observations and or measurements. And cross-cutting concepts would be patterns and cause and effect relationships. For the connections among STEM practices, this would fall pretty heavily under science and engineering, all of those practices that fall under conducting and carrying out an investigation. Under technology, I thought this would be making informed decisions because, like the rubber mulch, is a technology that's been developed and it may or may not help society and our environment. And then the mathematics piece would be all the measurement that went along with running the model, measuring the results, that sort of thing. I hope you enjoyed my erosion experiment. I enjoyed doing it outside on a nice day today. Thanks.